beautiful people, and welcome. In today's video, we're going to be talking about graphing polynomials. Now, this video is going to be full of examples. If you have not already watched the previous video on the steps of how to graph polynomials, make sure you're watching that before this video. We're just going to jump into some examples, and as always, if I make a mistake, please let me know where the mistake occurs so that way we both can learn from my mistakes and you don't have to make your own. Let's go ahead and get started with example 1. Now, I did write example 1 in the previous video, however, it kind of turned into a Q&A video, so we're going to do example 1 as well. However, we are using that video to create our steps to how to graph polynomial functions. Kind of not straight, but that's okay. All right, let's go ahead and write out our steps. Step number 1 is you're going to identify the total degree of the function. Now, if you're using the leading coefficient test cheat sheet that we created, your total degree would be your n. Step number 2 is we want the leading coefficient, which is a. Step number 3, we want to identify end behavior. And literally for the behavior, you just want your what it's going to be, the end, so on the right-hand side and the left-hand side. And I'll show you what I do here, but I'm just going to write end behavior. Once you have your end behavior, you're then going to identify your zeros or your intercepts. And step number 5 is identifying the behavior at each zero. And once you have the behavior, step number 6 is connect them all. And you're only going to be using your zeros and end behaviors. So you cannot touch the x-axis, you cannot cross the x-axis unless you have a 0. All right, let's go ahead and identify. This is how it's going to work. Total degree of the function, anything that has a bubble or x, you're going to put a variable on it. So 3 is an exponent, 2 is an exponent. Notice how there is a bubble without an exponent, that means there's a 1. So total degree of the function is 1 plus 2 plus 3, that is 3, 4, 5, 6. So I have 6 here. Step number 2 is the leading coefficient a. Leading coefficient is just the number out in front, which is 2. So now we're going back to the leading coefficient test. We're trying to figure out if this is going to be kind of what the end behavior is going to be. So if we have a positive or a negative, so we want leading coefficient to be positive or negative. That's what we're looking for. 2 is positive. And our total degree is even. So for total degree, we want even or odd. For our leading coefficient, we want positive if you're looking at the leading coefficient test. And then so step number 3, we want our end behavior. So end behavior. So what that means is positive is going to go increasing or decreasing. Even will mean if the end behavior are both going to be the same or different. So even end behaviors are both pointing up or down, and then odd would be they're different. So if we have an even total number of degrees or total degree of the function, it is positive. Our end behavior is going to be going up or increasing on the left-hand side and and increasing on the right-hand side. So both increasing. And honestly, for end behavior, I just do this. So as x approaches infinity, y is also going to be approaching positive infinity. And as x approaches negative infinity, y is going to be approaching positive infinity. So both of them are going up. Once we have our end behaviors, we're going to identify our zeros. Now, this is what I recommend doing for zeros. Every x that you see You're going to draw an arrow. After you draw an arrow, you're going to ask that question that was in the previous video. That question was, what does x have to be in order for the bubble to be 0? So if I have x plus 3, that means I need negative 3 in order for this bubble to equal 0. Negative 3 plus 3 is 0. Same question, what does x have to be in order for this bubble to be 0? And that is negative 2. What does x have to be in order for this bubble to be 0? And that is positive 4. Now these are our x-intercepts. So for zeros, x-intercepts, we have an intercept. We have a 0 at negative 3, we have a 0 at negative 2, and a 0 at 4. So what that means is we have negative 3 comma 0, we have negative 2 comma 0, and we have 4 comma 0. That's step number 3. Now we have to ask for the behavior at each 0. For the behavior at each 0, what we're looking for is we're looking for the exponent for each bubble. So here's 1, here's 2, here's 3. So those are the exponents. So exponent is 1, exponent is 2, and exponent is 3. So for an exponent of 1, we have something that is linear, which means we're going to have a line. For an exponent of 2, that means it's an even bubble. That means we're going to kiss, even. So that means we're going to kiss. We're not going to cross it. It's going to be just like a parabola. And then we have an exponent of 3. That means we have an odd bubble. That means it's going to look like Mr. John Travolta. And that's going to be looking like a cubic. Okay, so now that we do that, we found out the behavior. So the next is connect only with zeros and end behavior. So how are we actually going to graph that? Here is our X and Y. Now here's the thing, only label what you need. Don't label it because this is only a sketch. You are not a human computer. You cannot do this because some of these, because they're so big, and this is in factored form, I mean, there's going to be stuff that goes off to negative 374 or 2005 positive. So be careful. Just do what you can. So I have a negative 3, 0. Don't even worry about your y's. And then negative 2, 0. And then 4. 1, 2, 3, 4. So that means I can only touch the x-axis 3 times. Now what happens is I can touch it, I can kiss it, or I can cross it only this many times, 3 times. Okay, so start out with we're doing, again, going through the steps, the same thing. Starting out with your end behavior. End behavior is we're going up on the left-hand side and we're going up on the right-hand side. So I'm just doing my arrows here, just so I know that I'm going to go up and up. Next, I'm looking at my zeros. I already did my zeros. Here they are, 1, 2, 3 zeros. Then we're doing what's happening at each 0. So what's happening at negative 3? So at negative 3, we have a linear bubble, which means we have a line. So I'm going to do a line. Now, you can do a line, straight line. Typically, it's going to be like a line that's sideways. Doesn't really matter as long as it's a line going through. A line. Then what happens is somewhere around here, we have to go up and touch this other 0 because a 0 means we are touching that x-axis at that point. So how do we get to that point? Well, somewhere here, there's some sort of bend. And then what happens at this point? At negative 2, what happens? At negative 2, we have an even bubble, which means we kiss the parabola. We do not cross. Make sure that you are not crossing for an even bubble. So what does it mean to touch or kiss the parabola? That means we're just going to graze it, and then we're going to go back down. Now, somewhere here is our y-intercept. We can locate the y-intercept. I'm going to hold off for that. And then we're going to, what is our behavior here? So what is our behavior at, what number is this? This is 4. So John Travolta. So John Travolta means that we're going to identify this as our vertex. Now I know I'm coming through here somewhere. Somewhere here, it's going to be a curve because I need to go back up. So I know that I'm going to be going this way. Make sure that you don't do it the opposite way. You can't do the opposite because you have to connect. Now, if you wanted to find the y-intercept, sometimes you are required to find the y-intercept, sometimes you don't. So in my class, unless I tell you to find the y-intercept, don't worry about it. But I'm going to show you how to do it in this example. To find the y-intercept, we're going to take our equation. We're going to take our function. Let's see if this is going to be quick. So x-intercept means that y is 0, but y-intercept means that our x is 0. So all x's are now becoming 0. And we're solving for y. So y-intercept is x is equal to 0. We're trying to find what our y is right here. Okay, so we have 2 times 3 times 2 squared is 4 times negative 4 cubed. So I know that's going to be a negative number. So 4 times 4 is 16. 16 times 4 is 64. And that's all negative, so I have negative 64. This is where I'm telling you, don't write something until you know exactly what that number is, because this is an approximation. So this is actually at negative 1,536. So somewhere down, way down here, we're going to call that negative 1,536. That's where it crosses the y-axis, and then it's going to go back up for a John Travolta bend and go back up there. Now, even looking at this, that gives me anxiety. Hold on a second. There it goes. Make sure that you have a function, so when you do the John Travolta, it can go either this way or it can go this way. But make sure you end up having a function. So the original way that I drew it was not a function. And so that's it. You have your graph. Again, you can only touch the x-axis however many times you have 0. So you have 1 0 here, 2 0, 3 0. So you have 3 points that you can have some sort of interaction with your x-axis with. All right, let's do one more example following the steps just like we did before. Trying to find a good example for you. Oh, let's do this one. I like this example. Example 2, negative x squared times x minus 4 is equal to f of x. Step number 1 is identify your total degree. Total degree is n. Leading coefficient is a, so then we have our end behavior. Remember for total degree of the function, we want all of the visible and non-visible exponents, so the hidden and the visible. So this is visible. I know I have an exponent of 2. However, here's a bubble with an x in it. That means there has to be an exponent. And if it's not seen, that means it's a 1. So total degree is 3. That means I have an odd function. Now we're looking at the leading coefficient, whatever number's in front. Now this number, there is no number. However, I do have a negative. That means my leading coefficient is a negative 1, and that means it is negative. So that means when it's negative, you're going to have a decreasing. Odd means your left and right are going to be different. So if your left and right are different and you're decreasing, that means you're starting out going up, but then you're going to drop down. So it's going to decrease from left to right. So let's go ahead and now identify what your zeros are. I believe that's the next step. Zeros, anytime you see an x, draw an arrow. And you're going to ask yourself, what does x have to be in order for that to be 0? Another way we talked about finding these is setting each bubble to 0. So if I have x in a bubble and I need to make it 0, what does it have to be? If I have x minus 4 in a bubble and I need it to be 0, what does x have to be? Well, in this case, in order for x to be 0, x is just 0. This one here, I'm going to add 4 to both sides. So what does x have to be? X has to be 4. Now, you don't have to do this. If you just want to ask yourself about the bubbles, that's fine. So that means I have my zeros or my x-intercept at x0 and at x is equal to 4, which means I have a point at 0, 0, and I have a point at 4, 0. Those are the only two things on my x-axis that even remotely we can get close to, okay? Everything else, we can't cross it, we can't do it. So we have 2 points on the x-axis. Those are the only two things on the x-axis. Now we have our zeros. Now we're talking about the behavior. We're looking at the exponent for each zero. This exponent right here for x with our 0, that is an exponent of 2. So exponent of 2. This one here for our 4 has an exponent of 1. So that means I have a even function, not function, even bubble. Let's call it a bubble. Even bubble, which means I'm going to have a parabola shape, which means I'm going to kiss the point and I'm not going to cross. So it's going to look something either like this or like that at that point. We just don't know what it is because we are not graphing it just yet. Now this one has an exponent of 1. That means it is linear. That means we're going to have a line. And we all know what a line looks like. Let's go. I think that's it. Following my steps, trying to see what my last step is. How does the behavior, that's the behavior. And that's it. Now let's graph. Again, don't worry about your y. Just draw the points that you know. So I know I'm going to have a interaction with my x-axis at 0, 0. And I'm also going to have an interaction with my x-axis at 4, 0. Those are the only two that I'm going to have interaction with in my x-axis. Can't get close to my x-axis other than those 2 points. I'm going to identify my behavior, my end behavior. My end behavior is decreasing. It's an odd function. That means I'm going to have it being going up there, and it's going down here. It's opposite because it is odd, and it's negative, meaning it's decreasing. All right. Then what do we have? Then we have what behavior is at each point. So at 0, 0, we have an exponent of 2. That means we have a parabola. We're going to kiss that point. We're going to just graze it. We're not even going through the x-axis. We're just going to kiss it. Next thing we have, what do we have? We have a linear. That means there's going to be a line going through it. Now, somewhere here, we don't know where that is. It could be here. It could be all the way up here. It could be all the way to positive 275. You know, we don't know where this is at, so we're going to approximate it here, and it goes down. So it has to meet your end behavior. So if this is increasing here, it's going up on my left-hand side, it's going down on my right-hand side. So my end behavior, as x gets bigger, my y gets smaller, goes to negative infinity. And as x gets infinitely smaller, if it goes that way, my y gets infinitely bigger. So that's my end behavior for this graph. Okay. And that's it. You're done. You've graphed it. Here's your 0, here's your 4, and that's it. All right, beautiful people, that wraps up this video. I hope you enjoyed it. I personally think this is super duper fun. We're going to do a lot more in class. As always, thank you so much for watching this video, and I will see you in my next one. Bye.